Let's assume that the hourly wage is $15. Given a dataset where you know how many hours a person has worked for over the last 5 days, you can directly multiply the dataset by the hourly wage to calculate his daily earnings, as shown here. And if you want to calculate the total earnings of 5 days, use the sum method. You can see how the sum method adds up all the elements of the daily wage array. You can use NumPy to compare data as well. Let's say you have a dataset showing the total hours per week a person has worked for during the last 5 weeks. If you want to know in which week the person worked for more than 40 hours, set the criteria using the greater than symbol, as shown here. Note how only the weekly hours array elements greater than 40 are displayed in the output. The not equals function can be used to identify all the elements in an array that are not equal to the specified value. Here, as none of the array elements equals 40, they all appear in the output. You can also use NumPy for logical operations. Suppose you want to extract only those values from the weekly hours dataset that exceeded 20 hours but is less than 50 hours. You can use the AND method to get a Boolean array, as shown here. See how we are using two conditions, greater than 20 and less than 50, and combining them using the AND method to specify the range of values that we are looking for. You can use the NOT method to find out which values in the weekly hours dataset do not exceed 35 hours. You have seen how to use the add, subtract, and sum methods, and how you can multiply a value over the entire array. You have also seen a few logical and comparison operations. Let's try to understand how to access elements in an array. Cyclist trials is a 2D array and can be visualized as the diagram shown on the slide. To access the first trial data of all the 4 cyclists, refer to axis 0. Similarly, refer to axis 1 to view the entire second trial data. Using the same dataset shown earlier, you can see how individual elements in the array can also be accessed by referring to their specific indices. In this case, the first cyclist's first trial data is in location 0, 0 of the array. So to access it, you must reference it as shown here. If you want to select the first cyclist's data for both the trials, you should use : to select both the rows of the array, and then specify the column index, which is 0 in this case. Slicing is a data wrangling technique to access a particular range of data for a given dataset. The first code snippet shows that it is an array with 2 rows and 4 columns. The rest of the code shows how to extract data for cyclist 2 and cyclist 3 for both trials. Note that : is used to indicate that both rows are to be included. 1 indicates the starting index, and 3 indicates up to which element the data needs to be sliced. It's important to note that the actual ending column index of the sliced data is 1 integer less than the index number mentioned in the syntax. Use iteration to go through each data element present in the dataset. The bottom code snippet shows how to iterate through the extracted dataset and print it. These are some good data science practices to interpret and understand data by creating a subset of a larger dataset. Boolean is a data type which holds the values true or false. Using Boolean arrays is a common technique to check whether the data elements in an array fit the given criteria or not. Data scientists can then work on a normalized dataset. In this example, the array contains test scores of 2 students. Let's assume that the passing test score is 60. The data cells highlighted in red are the ones which fail the given condition. After applying indexing with Boolean technique, we get the normalized dataset. Note that it's a reduced dataset and all its values hold true to the given criteria. These are the rules of the game. Choose the first element of the range. Then, choose the element that ends the range. See how the values in the statement change according to your choices. Refresh to try again.